Most of Britain's nuclear power stations were built in the 1950s or 60s, and at the time, very little thought went into what would happen to them when they reached the end of their useful life.
Yeah, and now across the UK, many of them are in various stages of decommissioning. And Chris Vallance has been to Dounreay in the far north of Scotland to find out how its engineers are using robots to help in the process.
The ruggedly beautiful and windswept coast of Scotland. In the 1950s, this remote spot was chosen as the test site for a new technology, fast breeder nuclear reactors, capable of producing more fuel than they consumed. The steel sphere is there for a reason. If things went seriously wrong inside, it's designed to contain any radioactive contamination. The plant closed in the 1990s and is in the process of being decommissioned. It's a huge site, nearly 200 separate facilities, over a quarter of which contain a bewildering array of radioactive materials. Dismantling Dounreay is a huge challenge, but it's also become a test bed for new technology. But before we can go inside and see it, we need to dress for the occasion. They've gone to get me a bigger size.
Chris, welcome. This is a Dounreay fast reactor.
Well, would you look at that? Goodness, what a thing.
It's a big metal ball, a containment ball that was built here way back in the 50s. It's a couple of inches thick of metal, sealed, 10 unit, that's housing a reactor that sits over here.
And the reactor is slowly being taken down.
Slowly decommissioned, yes. We want to put it back to what it was previous to what it was in the 1955.
Doing that will take a long time, but they do have help. You've probably seen these four-legged robots before. Here, with the help of expert operators, Spot has been used to map out areas of the plant and measure radiation levels, information that will be vital when it comes to taking it apart. But for now, Spot's mission is to take me to its owner. There we are, we've got Spot, the Boston Dynamics Spot. Why this robot for this place?
Why this robot? Well, it's very, very common in the field of robotics to say that if a job is dull, dirty or dangerous, send a robot in.
You went into a fuel cell that hadn't been explored for 25 years.
We don't have a whole lot of information about this facility before we go in. It's like going into another world in terms of then having to explore that for the first time. So you take your first tentative steps in there as a robot enters this completely unilluminated but highly complex environment. We're able to start building up this image of where the radiation is. So then at the end of it, we can produce a 3D model that then gives the engineers just this amazing data set that informs how they're going to decommission this whole facility.
And it's interesting, Spot is wearing protective clothing like we're wearing protective clothing. You see that on the film and you see it here.
That's right, yeah. So Spot is currently in our contamination control suit. When Spot has been put to work, has been used for, it was a period of 5 days, multiple deployments. At the end of that, we can then clean the suit, we can remove the suit, and then Spot is then totally safe to then come away from site, having got no contamination on it.
Operating an expensive robot inside a nuclear reactor is a bit nerve-wracking, but surprisingly simple. Okay, all right, so this is just a regular tablet, isn't it?
Regular tablet,
all right,
yeah.
Okay,
so your left stick,
yeah.
If you move that forwards,
so you push up like that.
So you tap and push it upwards, and the robot will move forwards.
Good
It's
grief.
the same for backwards as well. And if we turn this one to the side,
Which
to
way?
To the right is fine.
Okay.
Over to the right, and then it rotates.
That's amazing. Good dog. They're proving very useful, and they're very cute. But the decommissioning and cleanup at Dounreay is a huge task.
I've got 3 nuclear reactor plants from the very dawn of the nuclear age. I've got a whole reprocessing plant for taking the the fuel and dissolving it and reprocessing it and dealing with the waste. I've got waste storage facilities. I have to transport the waste. So we have an awful lot of infrastructure that comes in lots of bits and pieces.
Decommissioning everything on the site will take decades, and it's been estimated it will be 300 years before the land is safe for reuse.
Well, that's for the site is completely clear, the intermediate level waste has gone to long-term repository. We think we'll have this place down 40, 50 years is our latest estimate, but there's huge variability to that. Nobody's ever done this. You know, I'm projecting things forward, and we know how fast technology is developing, so we're really excited that the technology can help us.
We've shown the benefit that these robotics can bring. I think that even if we look into the very immediate future, that it is absolutely credible within highly technical industries that we'll have robots walking around autonomously, carrying out their missions, and people will see them just as business as usual.
Well, it's been a fascinating visit. When this place was built, it was pioneering nuclear technology, and now new technology is being used to help with the decommissioning and the cleanup. It's time to leave.
Measuring.
But before I go, I have to make sure I don't take anything radioactive with me.
Monitoring complete. Please leave.
All clear. Spotless, you might say.
Now, what's your favourite 3D printed thing that you've seen?
My reading glasses. They are the one thing that makes me feel better about my ageing eyesight. Oh no, is that what you look like?
Yes, it is. Yeah.
Scary. How about you?
I think it's either the 3D printed house that I saw last year or this little helter-skelter that I made for my son's marble run about 10 years ago. I know, right? So you can 3D print all shapes and all sizes and pretty much anywhere these days. But what about underwater?
Yes, Alistair Keane has been to see one startup that's hoping to protect the oceans from coastal construction.
Is this one of the most satisfying bits of tech to watch? But this 3D printer isn't just pleasing on the eye. The walls it's creating have the potential to change our impact on the planet.
So one of the big challenges of our city, Miami and all coastal cities, is rising sea levels and flooding. And traditionally, cities have addressed this by building seawalls, which you see all around us, even here. And the problem with traditional seawalls is that they destroy marine habitats. Traditional seawalls leach chemicals, and very simply, they're flat. So when you have a flat seawall, the organisms that live by the coast, they can't attach to this flat surface, so they migrate. And they're where they want to be eating all the toxins in the water. So once the sea life and the organisms migrate, no one's there to eat the toxins, and the quality of water goes down 50% within 1 year of installation.
The challenge for Kind Designs was coming up with something that was economical for communities, but will also enhance the underwater ecosystem. And they think they've got it. These are the walls that you create. Talk us through some of the features.
Okay, so there's 3 really important features why these make these walls so great for marine life attachment. One, you have these little micro textures on the wall. And so if you imagine a rock climber, if they're trying to climb on a flat wall, it's impossible, right? So same for sea life attachment. Then, just the nature of the 3D printing process, you have all of these layers on the wall. So these layers are great actually for coral growth. And then lastly, you're not just having your kind of bottom of the food chain on these walls, but because of these caves, you get so much more biodiversity. So every species, their number one thing is that they want to survive, which makes sense.
Us too.
Yeah, us included. And so with these caves, as you can see, they're really deep. I can fit my whole arm in here. So that's where your larger organisms can hide from predators. And that's what really, really encourages sea life attachment and the amount of biodiversity that you couldn't get anywhere else but a natural coastal ecosystem.
It takes just under 1 hour for a wall panel to appear before us, much quicker than traditional moulding and setting of concrete. But this way of manufacturing also...
And so, since we're just producing in Florida right now, we're keeping this design. But as we expand nationally and globally, we can alter our design to make it fit the coastal habitat in any region of the world.
You're printing with concrete, which is still one of the most unenvironmentally friendly materials there is. Are you looking at other materials, or is concrete the only answer here?
We are using concrete, one, because concrete seawalls are mandated in many areas. You can use like vinyl seawalls, basically plastic seawalls. The problem with them is microplastics are leaching in the water, so also a problem. And two, you can only use them in areas that are very low impact, like a river in Orlando or lakes. The difference between traditional concrete and ours is non-toxic, so it doesn't leach. There's no chlorides, there's no metals, and it's also mixed at a 30% lower temperature than traditional concrete, further decreasing the carbon footprint. And that's just a starting point. As we democratize this product and have more of a margin, we will incorporate more and more components to our materials that keep pushing the limit on how environmentally friendly the concrete mix is.
This startup are installing their first walls in Florida now. Studying their impact will be vital in assessing if they make a positive difference and in what direction the designs will go next.
And that's all we have time for this week.
Thanks for watching. We shall be back next week.
See ya.